Hello everyone, welcome to Equal To, and this is the 6th episode of our Polynomials playlist. If you haven't watched the past 5 videos yet, please go and check that before watching this one. Now, in the last video, we have been solving the example problems, and moving on with that, we are going to solve the rest of the example problems in this section. So, those would be example 3, 4 and 5. Okay, let me just start with example 3. I don't want to blabber around. Okay, so let me just read the question first. Check whether minus 2 and 2 are zeros of the polynomial x plus 2. Okay, so a couple of questions might arise to you. Okay, so what do they mean by zeros of the polynomial? So what is a zero of a polynomial? Okay, so a zero of a polynomial is basically a value. If that is substituted, you would be getting 0 as the entire value of the equation. So what do I mean by that? Now that we'll get to know with this equation, but let us just say we have the equation here as p of x is equal to x plus 2, right? This is a polynomial and its p of x is equal to x plus 2. Now a zero of this polynomial is that value. If you substitute that value here, let us say we have a zero of this polynomial, and if that value is substituted here, we know how to substitute things, we have seen in the previous video. If that value is substituted here, this entire expression or this entire polynomial will become 0. Okay, so that is how it got the name zeros of the polynomial, right? If that value is substituted, the expression would have 0 as its value. Okay, so that is the 0 of this value. Now we are given two numbers, right? Minus 2 and 2, and we are going to check if those are zeros of this polynomial. Okay, now if you haven't gotten the hang of it yet, please bear with me, you'll get it in a minute. So p of minus 2, right? So this basically is substituting like in the previous example. So p of minus 2 is equal to minus 2 plus 2, right? So it's basically substituting the value, and that gives you 0. So what is the definition of a zero of a polynomial? If that value is substituted, the entire polynomial's value becomes 0, right? If minus 2 is substituted, you get minus 2 plus 2 as 0. So the polynomial x plus 2, when you substitute the value minus 2 in it, you get 0 as the answer. So minus 2 is a zero of the polynomial x plus 2. Okay, for the polynomial x plus 2, minus 2 is a 0. Okay, now we have to check for the other number, which is 2, right? So p of 2 is equal to x plus 2, that is equal to 2 plus 2, that gives you 4. Okay, now 4 is not equal to 0, so this is not a zero of this polynomial, and plus 2 is not. Okay, so minus 2 is 0 of the polynomial, but plus 2 is not a 0 of this polynomial. Okay, this is quite simple, there is nothing to get confused here. We are given two values, right? Those two values are minus 2 and plus 2, and they want to know if those are zeros of this polynomial or not. You are just going to substitute these values in the equation and going to evaluate it and going to see if those values make the equation's value as 0. In case of minus 2, the entire equation's value becomes 0, so it's obviously a 0 of the polynomial. So you might be hearing 0, 0, 0, 0, 0. So not a lot of zeros. We just have to know that a 0 of a polynomial, when it's substituted, the value becomes 0. Okay, that only statement, if you know, it's fine for you. Okay, so that is all for this example. Now moving on to the next example, find a 0 of the polynomial 2x plus 1. Okay, now this is somewhat different to the question, or somewhat different to the previous question, right? In the previous question, we were given a couple of variables and we are asked if those are actually zeros of the polynomial. Now in this question, they want you to find the 0 of the polynomial. Okay, so how are we going to do that? That is going to be pretty simple as well. Okay, so P of x is equal to 2x plus 1. Sorry, let me just write it again. 2x plus 1. Okay, so this is the polynomial that we are given. Now, we are going to find a 0 of this polynomial, right? Let me just make the brush bigger. Okay, so what we know as the 0 of a polynomial? So, if a 0 of a polynomial in the sense, it means that the P of x itself becomes 0. Okay, for some value of x, if P of x becomes 0, that value is called the 0 of the polynomial. Okay, so for that, P of x has to become 0, right? Only then the value of x that is assumed would be your 0. Okay, so how do we do that? So 2x plus 1 is equal to 0, because that is what we want. Only then the value here for x would be the 0 of the polynomial. Okay, so the next step could be 2x is equal to minus 1. Okay, so we are subtracting 1 on each sides, or you rather, if you want to tell, you are taking this positive 1 to the other side, that becomes negative 1. But the actual thing that is happening here is you are subtracting 1 from both sides. Okay, so 0 minus 1 becomes minus 1, and here we have plus 1, so plus 1 minus 1 becomes 0. Okay, so 2x is equal to minus 1, and in the next case you are dividing both sides by 2. Okay, so that gives you x is equal to minus 1 by 2. Okay, or in other terms, we have 2 in multiplication. If you take that to the other side, it becomes division, so it becomes negative 1 by 2. Okay, but that is not the right way to tell it. You are subtracting both LHS and RHS by 2, and that gives you x equals minus 1 by 2. Okay, so now you can say x equals minus 1 by 2, right? So minus 1 by 2 is a 0 of this polynomial. Minus 1 by 2 is a 0 of 2x plus 1. Okay, minus 1 by 2 is 0 of this polynomial 2x plus 1. So that is the answer to this question. It's quite simple. We know the definition for 0 of a polynomial, and that is why we are equating the polynomial to 0, and that will, if you try to solve that equation, basically you are trying to solve this equation. Okay, so this is a linear equation. We know what linear equations are, right? If the degree of the polynomial is 1, it's called a linear equation. Basically, on solving that equation, you get the value x equals minus 1 by 2, and that is the 0 of this polynomial. Okay, so that is it for this example. Moving on to the next example, and this is the last example for this video and also for this section, right? In the next video, we are just going to see the exercise. So the last example, let me just read the question first. Verify whether 2 and 0 are zeros of the polynomial x squared minus 2x. So we have the polynomial x squared minus 2x. So let me just write that out here. P of x is equal to x squared minus 2x. Okay, so this is the polynomial, and we have to verify if 2 and 0 are the zeros of the polynomial. So this is basically similar to the example we saw before the previous example, right? The one before that. So basically you are just going to substitute these values, and you are going to evaluate it and see if that comes out to 0. If yes, these are zeros of the polynomial. So basically that is what you are going to do. So P of 2 is equal to 2 squared minus 2 into 2. Okay, so 2 squared is 4, and 2 times 2 is 4, and that gives you 0. So this 2 is a 0 to this polynomial. Okay, now we are doing that for the other number as well, which is 0. P of 0 is equal to 0 square minus 2 into 0, that gives you 0 minus 0, that also is equal to 0. So both these numbers, both 2 and 0, are zeros of the polynomial. Or let me just not write that and write the equation straight away. Zeros of x squared minus 2x. Okay, both 2 and 0 are zeros of the polynomial x square minus 2x. Okay, so this is simple. This is no rocket science, it's quite easy. I know you got what we did. It's very simple. You are just going to substitute the values and evaluate the expression and see if it adds up to 0. If yes, those are zeros of the polynomial. Okay, so that is all for this video, and we have completed 3 example questions in this video. I hope you understood them. If you have any questions, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.